the hell? Stupid compiler left this away. So the -1 is correct, or looks correct to me. That is, all epsilons should be set to 0. Actually, I commented it out. But they should be, which means that all of this is 0. And I is 0 and j is 1, so I take the partial derivative with respect to c0 and then with respect to c1. That gives us this -1 here. So, yeah, okay. But my vectors thingy thinks that it should be 0 instead of -1. Why? Why? Okay, so call is 0 for I is 0 and j is 0. And then I think that should be this one. It's more like a row here, but okay. It's a column in the comment above. And then j is incremented corresponding to an increment in call. So we get C0, C1, and then C0, C2, C0, C3, because that is CI, CJ, as it says here. And every time call is incremented 1. So call is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And right at this moment we are talking about the 0, 1, and then call is this one, or no, it means call is 1. That's what I saw. Call is 1. Yeah, well, I don't know. I would say we're talking about the part where all the epsilons are 0, so this line here. And then the factor of C0, C1 is minus 1. Pretty sure it should be minus 1. So something wrong with this table then. Getting factors call. There is a minus 1 in here. So what does the index mean? The 0, 1, 2, 3, 4, 5, 6, 7 index. Oh shit. I think I get the problem. I think I swapped the last three and the first something. And then changed that also. Maybe the first column should have been left untouched. So we have eight of them instead of 7, right? Yeah. And these are just 7. So I think the problem is that I should have swapped these. But we swapped these 3. Invert actually. So the epsilon 6 and epsilon 9 are being swapped. And here the 0 and the 5 should have been swapped, and these 2 lines swapped. And this one should have been left alone, which is the first entry of this table. So I'm thinking that there was a -1 here, and now there's a 0 there, which is then wrong. So let's have a look at the original file. Yeah, see, there's a -1 here, so that should never have been changed. Let's redo this, because I think now I know how to do it. I'm just copying it. I should leave the first column alone. Let's line these things up. It's what missing here. What? Oh. Can move this one also. Right, so I want to swap this column. Let's include the space. Swap this column with this one, meaning I can paste it here and then remove this, put that here, and I swap this one with that one. And I have to swap this one with that one. It's completely different. Oh, the hell. I don't know what I was doing here. Should delete it. Bang, that worked. Instantly no asserts. Get the part with epsilons. Guess this is also symbolic. Okay, epsilon, yeah, to take the derivative. So I need something symbolic. What I'm doing there, the GADF2 on mine is the one without epsilons. What? Oh yeah, without, mine is the one with no epsilons, I mean. So what then is left is just the epsilon part. Probably a better way. Do we even have this thing yet? Do I have this? I don't think I have it. Yeah, I have it. I was going to use the zero order. Okay, so it's not needed here. No. Yeah, well, at some point you just have to trust in the code, I guess. But this should be equal to the orange part here, except it is completely rearranged. What is fill in 0 there? Clearly says 1 here. I have an accessor for epsilons, not epsilon. Could add it, but well. So if I have an epsilon index type, I can get the pointer to the symbolic symbol by calling epsilons. And and then treating that as a vector. Unbelievable. No, everything works. Thought I already committed that with the comment. Make this work for enum classes. Oh no, there was something else also involved. That's what? Yeah, this one. Nope. Oh man. Mixing things up, apparently. So I still have to commit this one, okay. Just kind of the bug, but not a bug. It's a compile bug. So it's a bug that it works always unless it doesn't compile. But yeah. What is the other thing? Non-built-in. I'm thinking hard if I want this, or maybe I don't know. No, I don't know. It's just let's just do this. Just literally copies without type. Doesn't come up with something original. It's always saying. I think you can leave out the strings. You can just call it digits, right? Into digits, or yeah, also not. I'm gonna call it 2 digits string. So instead of 2 string, so instead of subscripts, we'll just use digits. And then you have both of them. And it's probably almost the same as that thing. Let's just move it. Shut up. Or is that a subscript? Theoretically, this is exploitable. So it pains my heart to do this. No, it is not exploitable. Well, it would be if it didn't fit. So this is a signed long. I can't even get it to become negative. So it always fits in a size type because it's always positive. Yeah. Plus this distance is at most, well, per definition I would say, the size of this array, which is pretty minimal. 4 times 1 plus the number of digits in an int. Yeah, that cost is just perfectly fine actually. Thought like an attacker could print an integer that is so big it doesn't fit in a log. Need an unsigned long with the size or something like that. Del. Digit string. Finally. I'm inclined to think I want to use it always, actually. Is this hardly readable? Oh, what I'm good status. Let's commit this first. Oh, fuck me. I have the minus sign here. So that's no longer necessary then, is it? Yes, let's not do that then, because now we can print negative numbers. think I called it it. No, I honestly can't remember how I called it. Use it, yeah. Yeah, of course. Makes way more sense. What did I say? Okay. I tapped too many things in between starting stuff. Okay, there's my formula. This is the error. Plus or minus the square root of that. Okay, next step is the following. In the meantime, I forgot which test executable here needed is. That was one that did draw or something. What was it? Yep, same thing. It's just, my memory is so bad. A few days ago I had the exact same problem. I couldn't even remember which project it was part of. So I spent a long time searching for the thing the program that draws this thing with a vertical line that becomes noise. And I can't remember anymore how it is called. Or what project it was part of. Oh, this one. This was the one. Yeah, okay. Print roots. Example that one. So. Yep. So now we are passing this thing, a third-degree polynomial, and I want that I want this program to use the formula that you just saw, the formula 1 page big. And I must apply that to this thing, which is then becomes a, this is C0, C1, C2, and C3. So these are constants. But the x is still remaining, so it just then becomes a function of x. Yeah, well, let's just begin with adding it, I guess. So that comes from this one. We're going to put it in here. And the header that I'm going to need is square. Where are all my headers? I already have square. There's no way I need only these. Why do I only need these headers? Where is my symbolic? Oh yeah, yeah, okay. I didn't see it. So we need this. Let's put that here. That introduces the constants C0, C1, C2, and C3, and X, the variables that we're going to use in the calculation. So yeah, these are all the variables that are used for our third-degree polynomial. And this is the header that I need to be able to generate that formula for the floating point round-off error. No, I don't already have these. I want them as well, I guess, because in the debugger you probably want to be able to print it. I have one for an imperial. Let's add these as well. Yep, and then we need to using namespace. Yeah, it's a big one, big namespace. So let's copy this as well then, and I need to declare an expression manager for it, and of course do that, so we actually can use those variables, which then would allow me to create, for example, the polynomial itself, as we do here. I think I need it, so let's copy all of this. And then in the end we want the Haley's method. So yes, this uses FA and DFA and C3X. Just copy everything so we can print it again. So we see that indeed we can print it again. I guess I'm not interested in printing this at all, but if I am, then at most at the error itself. Let's see if this works. Amazingly, it simply compiles. So that still prints this thing, and now also calculates and displays the formula that we need. So now if we fill in the value of C0, 1, 2, and 3, and there's a bug here, it still prints, oh damn it, 0, this is for the subscript. If there is no subscript, okay, let's fix that first. So printing of a symbol. Oh, what's... Find the last non-digit character in the name. I'm lazy, so I'll just ask Claude. Oh, this is lost. Yeah, wait a minute. Follows not of digits. Okay, so it simply returns then something that points to the last character. Yeah. What is this? Empty. Only digits. No, it should not be possible. But it is only digits or empty. It's the name of a symbol, so I'm just gonna be concerned with this. If this equals to that, then we don't have any digits. No. Oops. What was I thinking? No. Again, that works. So no, X doesn't have anything anymore. Yeah, well, I don't know. Let's pick some X. Let's say the one in the middle here, -10. Or is that, that's not X? Just bullshit, what am I saying? It is log 10 of the difference here. So we're all very, very, very close in the neighborhood of the root, apparently. I think that we should start with setting the C0 stuff. So I want to run over all the variables. No, I only want to run over all variables. All the coefficients. And of course I have no idea how to do that, but we did that. I did that already in the previous program. So like this. Set variable. I don't think we have a set variable, or do I? No, we don't. These are my variables, and the only thing I have is I give get variable. Gives me a variable thingy. I can use this. So I'm gonna do get variable. Maybe we should add a set variable. Now I think about it. You can just get the variable and then assign to it, or you can make an add-in. No, I'm going to use get variable I, and then we assign to that something. Oops, blop. Let's see if this makes sense. So the expression manager calls get variable with an I, which has a type that can only be applied to that vector. That is, it is a variables index, so this type. Therefore, this returns a variable. Oh, it's not like that. Yeah, a variable const reference, where the variable is this struct, and I want to assign to the symbol, unfortunately, but I can call just symbol on it. Looks very const, but it doesn't matter. It's the const here. You can just assign to it. So really I should do get variable dot symbol and then assign it. And you can assign a double, and the double must be equal to the actual value of my input, which was not processed yet. I have input here, but that's it. String is parsed inside a try. Yeah, whatever. Let's delete it, put it here. Yeah, I'm not even sure what this stuff is doing. Here we have the coefficients. So you can paste it here, but yeah, why not first do all of this? Calculate the D and the discriminant, and then it's probably denominator, I don't know. And we calculate stuff, and then more stuff. And then we do something if D is greater or equals 0, otherwise we don't do that, or special case title, generate a quick graph, add function. Okay, it prints a function here. Coefficients, parse string input. Oh, here they are parsed as a double, and here I'm parsing it as an imperial. But yeah, will never be more accurate, I think. Than a double. Only need them to be imperial here, so I can use them in imperial formulas to calculate the root super accurately. think it's safe to say that we can, let's do, after a parsing here. Do we parse and then create a cubic polynomial, print it, and then we do the stuff. See, so here we do something dangerous, basically. I'm calling get value. It just converts my variable index type to an int. But that means that whatever that value is must correspond now with the order in cubic. In other words, 0 now must be C0. Now it is, you can see that I expect that to be the case anyway, but actually no, not really. It's the other way around. It's for this one. So this C0 index must be 0, and then C1 must be 1, and so on, and this C3 must be 3. And that is only the case because I put them in this order, C0, C1, C2, C3 at the beginning of this macro. But yeah, you know, maybe sometimes, I mean, why would I not swap these or put X at the top or add another one at the top or something like that? So it is kind of dangerous. But yeah, it's just a test suit thingy, so I don't even feel like adding an assert for this. Now maybe a comment. And then while while drawing the graph, we have an X. I think I can calculate the X while we're doing that. And then I have to do this again, where we use X dot index. And then set that to the value of X. As soon as we have an X, that is. So let's see whether it's being calculated. This thing is working with quick graphs. Quick graph. How many quick graphs do I have? I have 2 of them. Quick graph. It function cubic. This is simply the cubic. We have 2 graphs. Maybe we should begin with this one. So I could add, can I add another function? Can I add 2 functions with the same graph? Probably. No. Copilot thinks I want to draw the derivative. Let's try that out. So cool, that works. This S thingy is the cubic, and then this thing here is the derivative. So you can see in the top it is 0. And in the bottom here it's also a 0. And if you go here, then it's very negative because you go steep down. And here it's also very negative because you go steep down. And it is of course positive in this region because you go up. So yeah, hello derivative. And now instead of that, I'm going to print out the use formula. And this is what I wanted to do. So I add a function, and that function is, well, knows the x value. So I can do this. Expression manager get variable x index. Symbol becomes x. Can just do that. Now you can evaluate the formula and then draw that. Is there a way to give this thing another color because it was a bit confusing? I can add a line style, or I can just add a color. I probably can. I have color black here, so I can just use color red or something. Comma. Yeah. Yes. Copilot is doing its thing again. It heard me say red, so. Let's see if this compiles and I still draw the derivative, but now in red. Let's see if that all works. Reference base type double it, yeah. Whoopsies. We reuse the X here. The symbol shouldn't move anyway. So let's make an X symbol outside of everything. So symbolic symbol cons reference symbol X. Where was it? Can't find it back. Oh, here. it compiled, and we have a red derivative now, so I would say it works. So now instead of drawing the derivative, I'm going to evaluate yes, nobody knows what it wants here, just evaluate. But evaluate what? The symbolic expression. And the symbolic expression is this is not a symbolic expression. Hell, error. I need an error. So you need error squared returns a symbolic expression. So we have the formula as a symbolic expression, and I can evaluate that. But it is the error squared, so let's call it like that. So we can evaluate that. And then I'm going to calculate the square root of that. And then to complete magic, you have to multiply this with 0.688 something, and nobody remembers what it was. Actually, it was 866. Where can I find that number back? I'll have to remember where I derived that. Maybe I can still find it back on Discord. Hold on a second. Yeah, I have it here. Nope, 3 6s. Ah, I should have remembered that, yeah. 7 5, that's it. And actually there must be the machine epsilon here also in. That makes it very small. How do we get that? I have no fucking clue. So that is the error, which is very small because we have just multiplied it with epsilon. Not interesting, I would say. So maybe I should just not multiply it with that for the moment. And in the hope to get to see anything, something. Yeah, there it is, the error. Wow. What a formula. Okay, it's not interesting what happens here, but it is interesting what happens here, I think. So let's divide this by 10 for now to see what happens. Although here, this is the root, huh? So we're going to be only interested in the extreme neighborhood of the root. And as you can see, that's just basically a constant there. All that work, all that work. No, I'm just kidding, because this is a not so interesting cubic. Exactly because it just goes straight through 0 here. So there's nothing special about this root. Okay, I'm gonna divide this by... Maybe should not divide it by 10. Let's just go straight to an interesting cubic. Well, in fact, it becomes interesting when it gets larger. So, yeah, we should divide it by something, I think. Let's divide this by 10 for the start. What is again? Go, go, go. Whoa, that spikes. That's interesting, isn't it? So the round-off error, the floating point round-off error is very large, around this and this point. What would be the reason? That's weird, man. That is highly weird. Very spiky. Let's divide it by 10 again. My God. I don't know. There's always a possibility that something is wrong. The values are not even useful. Okay, this looks more useful. This is a problematic cubic because the root is like this is the machine epsilon error, a little bit 2 times 10 to the power minus 16. But as you can see, we already saturate a factor of 100 higher here. So we'd say, well, then expect 100 times the machine epsilon as error, but if you divide it by 100 here, this is the green thing is what the error is. It's not really 100 times. 100 times would be 1 here, so that would be here. But okay, maybe close to 50. In other words, instead it's going to be 5 divided by 10 instead of 10 itself. Just divided by 10. Yup. No. So apparently the error, the floating point round-off error is, well, pretty high, exactly where the root is. It's close to 50 times the machine epsilon, which means a double can store a value that is 50 times more accurate than that we were able to calculate for this particular cubic. Okay, but the whole this I don't know. This is just not a very nice way to look at it. I think it is better to look at this here, which is double logarithmic, so you really see what's going on. And what I can do is draw the graph in this double logarithmic thingy. Although I'm wondering what the effect of that is, because this is the log 10 of the difference with the actual root. So this is 1/1,000th, this is 100th. I mean, if you just ignore the thing here, then it's all of this is incredibly close to the root. So if horizontally here we change x, yes, but hardly. Really, all of that just happens inside the green line, more or less. And as you can see, the error is not like total noisy here. It just looks smooth. I would say you can say that it is more or less stable here. Exactly in this point. So yeah, it seems to me that if I express that as an error on the vertical axis, then we just get a more or less constant line that maybe deviates here. The last little bit, but the rest is just a horizontal line. And where will that line be drawn? Actually, it is more difficult. It's not vertical, is it? This is simply the log 10 of y. So if we go to the left here, then we get closer and closer to the root, which means that y should get closer and closer to 0. But you can approach the root from two sides, and I think that should be the log 10 of the absolute value of that. The label is just wrong. So if we are on one side of the root, then we get black or red. And then if you move to this side, we go through the root at minus infinity, and then we come back. And then we get the other one. So one of them is red and the other one is black. And of course it's a diagonal line, because if you go to minus infinity to the left, then we also go to minus infinity vertically, because it's the calculated root. Root means that y value becomes 0. But around this area we have problems with calculating it at all, hence the noise and the saturation. So how do I draw in here my calculated error? What is the formula that I have is the error in X. So it's the error in this this direction, but also as a function of X. Yeah, I don't think the value will change that much, but it's a bit difficult to draw something in that is a function of the, that has a place on the x-axis here as function of the x-axis itself. I need to make another graph which just plots x horizontally and vertically, as it were. Or I can just draw it vertically and then interpret it differently. So we then say we get a, like I said, expect a horizontal line. So if we get a horizontal line at -14, like this, that means that it doesn't matter if we're incredibly close to the root or just 1/1,000,000th away from it. The error is then this size, -14 on this axis. For a living, is that a reaction on Discord? Yeah. Oh, the other one is not a quick graph. It's a full-blown, lots of code graph. So 4 curves. Plot curve 4, plot curve 3, plot curve 2 and plot curve 1. So you have 4 curves apparently. Now which is which? But this is simply the cubic itself. Why do I have two of those? So plus or minus the offset. Yeah. Yeah, this input here is literally what you see on the x-axis. So that runs from -18 to 0. And then we calculate the actual offset, so that's 10 to the power of that. And then we do 1 plus that and 1 minus that. And that's basically the epsilon, as it were. So, and then we do that. Multiply that with the root to get the x value that belongs to that offset. And then we convert everything back to log 10 of the y value of that cubic. So it can be drawn. Doesn't that mean that if I comment this one out and this one, then the cubic will disappear? I would think that's those diagonal lines, right? Yes, it is. So the diagonal lines were the calculation of the cubic itself. I think this is something theoretical. It just doesn't have any noise in it. It's probably calculated with multi-precision. Hello, Mitchell. Oh yeah, so this is a single step. Well, I could do that. I could do that. So I have a slider that is a single. Okay, let's comment this one out again, or in. So I have a slider value somewhere. I don't know where. Slider. There, slider. The slider value for xn, yeah. And then we do a single Haley step to get the value of xn plus 1. And for that x value, I can calculate now the floating point round-off error that we expect. How do we do that? It draws a vertical line at xn. What is this? Initial root found. Ground zero. Plot root found. Trust me that I have no clue anymore what this is doing. Though I wrote it. Sad fact. But yeah, don't need to. I can just go from here. We have this x value, so I want to fill this value in. Yeah, so this is the x end value. That is the initial value, which is then my x value, the original x value. So I want to set the symbol x just like I did symbolic x. This. Let's copy the whole thing. I think I have to convert this value now back to the x-axis in the same way as we do here. Log 10 of xn divided by the real root minus 1. But my error is already that. Yeah, so I just need to get the log 10 of it. Let's copy this. No, anyone see a purple line? I don't. Maybe this line here at minus 14. Doesn't look very purplish to me. What other colors do we have? So a bit unclear, I must say. Let's try navy. Moreover, let's make the line width just way bigger. So I know for sure that it is this line. Line width. Oops, there is no line width. How about width? There is a width. 2.0. Yeah, nobody knows. Absolutely nobody knows. Line color is also not highlighted. I'm gonna go for line width. And it compiled, so that was it. And it is indeed fat. It's now a thick blue line. So yeah, definitely, this is it. So the error of this cubic is -14, and like I expected, it doesn't really matter where the green line is. It's the x value here. -2 is very close to the root, and anything less than that is also very close to the root. So we just have to, we just here, and that is the error. It's kind of constant. So yeah, it doesn't move. Now at most it would move if you go all the way to 0. Then at 0, 10 to the power 0 is 1. So then we are at the root +1 distant or something like that. So maybe we are done here. So yeah, at that scale, it definitely goes up and down. So if we go up, then at some point it should shift. Still -14, -14, -14, -14, -14. No, -14, -14, -14, -14. No, it goes down. Less than -14. Significantly? No, significantly. It's less than -14 and less and less. Oh, even less. So I'd say that is diving from here down to less error. Then if we go even further up, we should go see that it goes a little bit up again, or maybe we went that way, and then go down again. Yep, goes up again. It goes even up more. And then it goes down again. So, it seems we understand how it works. But, yeah, once you get in this neighborhood of, say, here, or let's say, if you do a Haley step, if you have this x, then one Haley step jumps there, which is not near the root. But if we are closer to the root already, like this, for example, if we are here, or just 1/1,000,000th away from the root, then one Haley step should bring us to the red line here, which is already more accurate than fits in the double. And what -16, 2 times minus, so like here, that fits in the double. So there is no way that we can reach that, and that means that only one Haley step further we should be at the answer. And apparently it saturates at -14. This is the error that we expect. That is 87% of the cases the error is like this or less. Statistically. So we probably end up somewhere here instead of there. And then if you move, if you do another Haley step, then yeah, it doesn't matter. So I move green now to where the blue one is. Of course, we just fill that in. And then, yeah, I mean, the blue one stays where it is, obviously. There's no, we don't have enough precision to get better than the -14 here. So this -14 corresponds then with the top of this arrow function here. Let's try another cubic. I think this program is generating cubics. It's generating cubics that are probably problematic. So could you stick this on, say, why not? That is this one. Copy. So you see the same cubic, and then this is the arrow graph, and the root indeed is again in a peak of the whole arrow graph. This time not as bad as the other one. This one's not -14, just a little bit less. Maybe I should, yeah, it doesn't really matter. As long as you're less than -2, it's already saturated at whatever the arrow is. So the fact that this is all the way up around the -14 is the whole reason that I did classify the cubic as problematic. It's hard to calculate this empirically. It turned out to be hard to calculate the root accurately. And then we fill it in now in my beautiful new program, and that shows me that indeed that is the floating point round-off error that I expect. It is quite higher than what you can reach. So for example, if we do, if we just change it a little bit, let's say I make this 6, then it is already way easier to calculate the root. Now the error was here, a little bit less than -14, and now the error is here, so almost as low as you can get. And the reason is that now the cubic looks like this, so it just goes through the 0 here. So it's easy to calculate this root. And you can see why. The error is like, this point is lower in terms of error, but it's really low, the error here. The spike is here, yeah, but it's not nowhere near the root. So this root is easy to calculate. But let's do another one. Oh, what is this? This cubic has problems. It's just going steep through the root. So why would this cubic have problems? Let's investigate. This cubic. Copy. No problems whatsoever. There are no problems. It's as accurate as you can get it. I don't know why it stopped. Here as well. It's literally like the lowest point of the whole arrow graph for the root occurs. I think that what I do to determine if they are problematic is to see how many steps it takes before we reach accuracy. Now this one has an enormous spike around this area, so maybe we started at the wrong point. And then it just took a very long time before we arrived at the real route. Maybe that's why it stopped. But the eventual accuracy seems pretty high with that one. I'll try to find one that is I'm skipping certain types, by the way. I'm trying to analyze the cubic, and if I understand it already, I mean I already understand why it is hard to calculate, then I skip it. But the thing only stops on cubics that I didn't understand before. It seems that they're just kind of flat-ish around the root. See, again, the root is exactly where the second derivative is almost zero. The first derivative isn't even low, but the second derivative is like zero, like right there at the inflection point. Let's have a look at this cubic. So minus 14, 1 again. I think the first one was just the first one. It always stops when I start this program at the first one. But it's not problematic. Did I divide it by 10? I think I did, right? So the 1 here is actually 10. 10 times the machine epsilon. So that it's even, that's why it's even larger than 10 to the power minus 15 instead of 10 to the power minus 16. Okay. I have to think about this all before I continue. Oh shit. Yeah, that costs the whole piece. It's +6. Come on, I thought it was only 3 points. Oh yeah, I get this one back. You could put it there and then it's 4 points. At least Goya has a bad bishop. Oh, well, maybe not. Oh, the bishop could go there. Yeah, it's still bad, of course. Let's go here anyway. I have absolutely nothing. What? He even resigns. I don't get it at all. It was +3. If I take the rook, it's -2. Yeah, I don't think it was worth resign yet, but. Over there, over there. Probably should first have castled. Nobody knows why he doesn't take here. Still doesn't do it. Defending this pawn. Making room for my knight to defend this pawn as well. Yeah, can't give away my pawn. How quick is the queen coming here? Can I go here? I go here. Let's say it takes with tempo, but that opens this file. And then he goes here, threatens to give check, and horrible things happen, or not. And I can go here, front of the ball. I think I can go here. Goes to that diagonal, yes. Threatens a few things. So let's begin with blocking the pawn and attacking it and everything. Then nothing. Nothing. Oh, threatens check. Actually, that's annoying. It is quite annoying. Yeah, if you give check, I have to go there or there. Imagine I go here. Okay, I'll just do this. The man has got a pointer. Wait a minute, can I do this? Can I not? Do you have nothing variation? Plus he gave away rook, which was pretty much a mistake that he does not want to admit until this point. My god, I tuned in my bishop. Yeah, I was afraid of that. And the knight can go back here though. Over here, if I move the queen. Oh no. That was a royal fork. It's still two rooks being attacked. What to do. Oh yeah, I can't go here with the rook. I wanted to do that. There is a bishop over there. Cheer. Oh, the rook can't go here because of my bishop. So I should have played a knight, I think. Does it make that much difference? No, I'll definitely play a knight. Definitely. I could have taken the rook. Fuck me. Let's take the rook now. Yeah, that costs the bishop. No, take my pawn. It's free. With this open file here, he's like dead unless he castles short. But then this pawn is pinned, so I attack that pawn. Now he has to solve the problem. How to be able to castle. I don't see a way to defend this pawn, except with the knight maybe. Then you have to get rid of this, so he could take here. Then I take back, and then the knight can go where? This one knight can go here, yeah. But I just take it. The knight is defending that. That doesn't work either. So he can't castle. Oh, yeah, brilliant. I had not seen that one. Yeah. That unpins the pawn. It's a good move. Let's say take with the knight. This one is undefended, so I can give a check here, right? So I take. You take with the bishop, and I take, and you take with the knight. Then I give a check. Then the knight can go in between. Then I lost a piece. Yeah. But then I add another rook. I don't know. It feels like it should be possible. I don't want to lose my initiative here, really. I'm gonna check like this. Let's see what happens. Basically investing in a whole piece. So now I put the rook here, then he will just castle. That's not what you want. I can take here, that attacks the knight. I probably should take that, put the knight there anyway. And my bishop is still here. So you could check, you could put the knight there. Bishop is really in the way, damn it. I don't know, just try something. You can't castle. I have to keep the king in the center. Can't castle because I take the knight. true. This rook. Yeah, now he can castle. That is true. No, that's not good. This is not good. Already 2 points down. He can take here, I think. He can take here. That's 3 pawns, just too much. Oh. No, I don't believe that. I don't believe that. Can we win 1 pawn back? Maybe we should do that. Because of time. It's down on time. And then the question is +1 enough now? Or you can still pick up this one afterwards. Shit. Go to the 7th row, right? Check and mate. That's not good. I have to take it. But he didn't take this pawn then, so it's not that bad. Can't you do that, damn it? I'm losing this pawn, am I not? Looks like it. No time left. Oh no, give away that pawn as well. Shit. Oh, that's really stupid. And again. Yeah. The misery. Black is winning. Black is winning. Black is winning. Black is semi-winning. Okay, this was like lost forever. +2, +2, +2, +1. Should not have taken there yet. That was a horrible move. Because now he can, yeah, I missed that move. I definitely missed that move. So here I should have taken here even the previous move already. Yeah, it kind of makes sense. There's a weak backward spawn. My queen is on this file, so if I take here and it takes like that, then this square becomes mine. I can just put this piece there, this diagonal stays open. And if it takes back with that pawn, then he can't push this anymore, which means, well, this diagonal also stays open. So what I'm effectively doing here is allowing him to push the pawn and close this diagonal. Definitely with this move. That's just stupid. Now it's the draw, and I tried to sacrifice a piece. Okay, just only -1. Oh, now I make it -2. Yeah. Okay, my original plan was to give check, yes. It's apparently not that bad. He has to go back. And then I did look at this, but I was afraid that he would just push the pawn. And why is that not working? Oh, it is working. Okay, now my rook comes in. And he gives away the knight. Why does he give away the knight? Because he picks up that one. Yeah, good. It's not much. Anyways, let's go do something else. Okay, I'm going to stop the stream. I'll be back another day.